get that. Okay, couple quick housekeeping notes. As I'm sure you gathered, we started this session late, about 15 minutes late, because the keynote ran way over, and then they had to literally build the walls in this room. So that's why we're starting late. That's going to affect the sessions in this quad in the New Zealand 1, 2, 3, and 4 rooms, but it shouldn't affect any of the others. Now, however, I do have another session immediately after this one that discusses data encryption technologies in Office 365. I hope all of you will come there. It's right after this one in the Crowne Plaza Ballroom, which means, unfortunately, I'm not going to have time to take questions at the end of this session. But my email address is up there, so if you don't get your question answered in this session, or if you come to the next session, that one, or at the any of the hub gatherings, please do feel free to email me afterwards. Also, this session is being recorded, so if you have any devices that are going to make noise, if you could just silence those as well. And because it's being recorded, you'll have access to both the video and the slide deck afterwards. But that being said, you guys are more than welcome to take pictures of stuff on the screen if you want to. All right, so in this session, we're going to talk about tenant isolation in Office 365. How many of you have deployed production users on Office 365 so far? All right. How many of you think that you understand how the service operates and how we authenticate and things like that? All right, not as many hands. So that's good, because that's largely what we're going to talk about. As you know, Office 365, the standard enterprise commercial offering is a multi-tenant solution. Okay, so we're going to talk about how we do logical isolation of your data in that multi-tenant environment. Okay, if you're not familiar with a multi-tenant environment, it's an environment where you're sharing common resources like common servers, common network devices, and common disks, and so forth. Obviously, if this is a shared resource system, that means, for instance, in a given Exchange Online server, there's going to be mailboxes from multiple tenants located on there. Or in the given SharePoint Online server, there's going to be multiple tenants, site collections, and libraries hosted there as well. Now, in the multi-tenant environment, in order to protect it, we have two goals that we're trying to address from a tenant isolation perspective. One is preventing data leakage, so data from your tenant doesn't leak into another tenant, or data from another tenant doesn't leak into your tenant. And then secondarily to that, we also want to make sure that no single tenant can do anything that's going to cause a disruption or a slowdown or some sort of interruption in service for any other tenant. So it's not just about separating where we store your data and things like that. It's also making sure that given tenant isn't doing things in the service that we don't want them to, or more particularly, that could adversely affect another service. Now, we have a lot of controls built into both Office 365 and Azure Active Directory, which is the authentication and authorization layer that we use for Office 365. So between Azure Active Directory's identity, authorization, authentication features, and role-based access control, those are the two primary methods by which we achieve logical isolation. When I say logical isolation, that's really what we're talking about. You're not physically isolated onto your own hardware. You're logically isolated from other tenants on shared hardware. Now, in addition to that, we also use very rigorous physical security as well. So as an example, all of our data centers have gates around them. They're perimeter checked 24/7 by guards who are always there. In order to get in, you have to use multi-factor and biometric authentication. So in other words, you need a smart card and a handprint to get into some of them. Once you get into a data center, there's cameras everywhere watching everything that you may be doing. And then all of the data that is customer data, all of those racks are locked and marked with red tags to indicate that they are secure, and they've got constant stream of cameras trained on them as well. So very, very rigorous physical security goes into it. And of course, we do a lot of personnel screening as well. We have many controls that do things like do fingerprint checks, background checks, employment histories, credit checks, criminal checks, and things like that. So very, very rigorous screening for anybody who's going to be working in any capacity in Office 365 as well. And then on top of all that, there's a whole slew of encryption technologies that we use as well. I'm not going to talk too much about them in this session because, like I said, there's a whole another session after this on them. But there are lots and lots of different encryption technologies that also prevent disclosure and leakage or integrity violations of your data. In addition, there are also, the individual workloads also have some of their own abstract mechanisms as well. So for example, SharePoint does some extra isolation at the storage layer that I'll talk about in a bit as well. So let's start with Azure Active Directory. That's where we get our authentication and authorization layer from. Access through Azure Active Directory is controlled at the tenant level. Okay, so you've got a tenant in Office 365. It's associated with an Azure Active Directory tenant, and it is that tenant that is authenticated. Azure has an authorization layer, and it performs 3 basic checks for any request for authentication or any request for any sort of content access inside of any of Office 365. So we're looking to see, is the principal enabled? Is this actually an Azure AD tenant credentials that we're seeing? Is the principal, the credentials that we're seeing, are they authorized for data access for this particular tenant? And does their role allow them to access this type of data within this tenant as well? So all 3 of those checks have to pass before Azure AD will do any kind of authentication or authorization. And so generally what that means is no application, no user, no Microsoft admin, no piece of code. Nothing can access any data within Office 365 without going through this authorization layer. And anything that's not accompanied by the appropriate credentials is simply rejected and logged as an access failure. Now, Azure AD is actually designed like Office 365 for hosting multiple tenants in a shared environment. So Azure uses the concept of containers. Containers are deeply ingrained in the way Azure thinks of things. So effectively, each tenant in Azure Active Directory, you're seeing contoso.com up here, each of these tenants is in its own protected and isolated container within Azure AD. And it has its own set of policies, it has its own set of identities within that tenant, and they're all controlled within that single container. So even when, for example, there are multiple tenants sharing the same physical disk, those are still isolated and protected containers. So here you can see Contoso and Fabricam. They both have separate dedicated containers, and even though they share some of the same underlying storage and infrastructure, they still remain completely separate and completely isolated from one another from an authorization and access control perspective. The other thing to point out is all of Azure's directory information is stored within Azure Storage. And there is no way to make a direct connection to Azure Storage to get at the data. Every connection, anything that tries to touch Azure Storage has to go through the authorization layer. So there's no way to circumvent it and get to the storage directly in this model. So effectively, it's claim-based access controls for a specific container. So everything is scoped to a tenant, whether it's an authorization request, whether it's a read or a directory write, all of that is scoped to a single tenant, and that tenant itself forms a security boundary. The security boundary allows you to designate very granular roles through role-based access control. So you can have varying levels of administrators for Azure Active Directory, just like you can for the various Office 365 services as well. So by default, Azure AD disallows any action within a given tenant by other tenants. So it's up to you as the administrator, possibly, to allow another tenant access into your data if you chose to do so. But by default, everything is completely isolated and restricted to just the identities that you have within your tenant. Now, Azure AD is global. It's all over the world. This is just a small sampling of where we have it. But it's a global infrastructure. And the way we've divided it up, we call them partitions. So, for instance, there's a North American partition. There's a US government partition, also in North America, that's separate from the commercial one. There's ones in EU. There's a special dedicated one in Germany, and so forth. Now, partition information is really abstracted away from the users, and there's generally nothing that you would ever do as an administrator or as someone inside a UI that would interact directly with the partition. So really what I'm giving you now is kind of the behind-the-scenes look at the way things are architected. So a tenant exists in one partition, and partitions can contain multiple tenants, but a tenant will never span partitions. You'll never, for example, see a tenant in North America and Germany, as an example. Partitions are replicated to multiple data centers within that geo, the geo being, again, North America or Europe or APAC or one of the other regions we have. And the partition that you go into is chosen when the administrator signs up for Office 365 and enters the country that you are coming from. So whoever chooses that chooses the country. That leads to the country code, which determines what partition your tenant is going to be in. And there are secrets and other things that are unique to each partition that never cross partitions as well. Now, Azure AD, from a session perspective of Office 365 users, it looks like they have their own directory service. Okay, so everything is scoped within a user session, and again, gated by the authorization layer for that tenant, and taking into account their RBAC roles. There is also, like I said, a number of encryption technologies that we use. Azure Active Directory uses encryption, for example, for the storage and for the protocols that are used to access the APIs that are available in Azure, so SSL, TLS, and so forth. At the storage layer, they're also using AES 256-bit encryption. Again, I'll be talking about that in the next session. But that is an important part of the isolation that we do, not just encrypting it at rest, but also using encryption at the network layer as well. Now, it is a highly complex set of servers and storage and network components that make up Azure Active Directory and Office 365. There are dozens of services involved, not just Office 365, but other services. There are hundreds of entities with thousands of relationships and tens of thousands of attributes, many of which are application specific for the Office 365 workloads we have in there. And again, at a high level, Azure Active Directory are really just the directories of containers that are kept in sync with the other directory servers that are maintained by the other workloads. So as an example of that, over here you see Azure Active Directory. Here what you're seeing are the individual directory servers for each workload. So Skype for Business has its own set of directory servers. SharePoint has its own set of directory servers. Exchange has its own set of directory servers. Those are kept in sync with Active Directory through a directory synchronization process. So here you're seeing a single tenant. This is what multiple tenant would look like. There are separate OUs that are created within each of the service directories for a tenant that is designated to that tenant, and that is the replication source for Azure Active Directory, that actual OU within the online workload directory service. So that, by the way, knowing that there are other directory servers, hopefully that may explain why when you take certain actions in Office 365 or Azure Active Directory, things don't take effect immediately because it will take a while for it to replicate throughout. When you make a given configuration change, for example, we have to do not just a synchronization within that data center, within the active data center where you made that change, but we also have to go to these directory servers and then ultimately over to Azure AD as well. So it can take a little while for things to replicate around if you're making a bunch of changes. But it is, as you can see, a fairly federated model with Azure AD being, again, the authorization layer that gates the view of the data. OK, so let's talk about Exchange Online. So I would hope everybody in the room knows that the data in Exchange is held in mailboxes, and that could be things like emails, attachments, free busy, calendar information, tasks, notes, and group information if you're using Office 365 groups as well. And then there's also inference data, which is driven by the Office Graph and some of the features that we have in there. And I'll talk about Office Graph in a little bit. The mailbox, if you are also a Skype for Business user, may also contain some Skype for Business data as well. For instance, it could have conversation histories or meeting information in there as well. So everything in Exchange, from a user's perspective, is held in a mailbox. Those mailboxes are hosted in mailboxes databases. And those could be a user database, or user mailbox rather, a shared mailbox, a linked mailbox, and so forth. But they're all in mailbox databases. And each mailbox database within Exchange Online has mailboxes from multiple tenants. So when you deploy 50 users, they're not all going to go on the same database. The service will figure out where to put them based on an algorithm that we have. And your mailboxes are going to be sharing a database and sharing storage, therefore, with other tenants and their users as well. As is the case with Exchange Server, out of the box, nobody has access to a given mailbox except the associated user. The mailbox is actually an attribute of the security principal of that user. So by default, nobody has access to the mailbox except that user. Mailboxes for a given tenant are limited to the identities within that tenant. So whatever authentication provider you end up using, whether you're using maybe ADFS or Azure AD or whatever, authentication is always and only going to be limited to just those identities that you set up. So unless and until you set up an account, there's going to be no access to that particular set of data. Sorry about that. I think I went too fast. Oh, there we go. OK, so Skype. Skype stores its data in a variety of places. So we've got the user information and account information that is stored in the Skype for Business directory servers. You saw the triangle on the other screen that has those. And then if you are using Exchange with Skype, we'll store your contact list inside your Exchange mailbox. If you're not using Exchange and Skype, but you're just using Skype, we'll store the contacts inside a Skype for Business server. But generally, most customers are doing both. And so they'll have their data stored in the mailbox. The database servers themselves are not partitioned per tenant, so there is commingling of data. But again, Azure AD, and in particular the RBAC roles, are there to provide that logical isolation for you and prevent data leakage. There's also meeting content that Skype stores as well. And this is content that gets uploaded by any user who's a member of the meeting, and that ends up getting stored on DFS servers that are managed by Skype. Okay, so as they're DFS servers, they are also replicating that data as well. This content, by the way, if you have archiving enabled, won't just be on the DFS shares. It will also be archived per your archive policy in Exchange. And the DFS shares, again, like the other store, is not partitioned per tenant, but there are ACLs, and RBAC is also enforced here for the data as well. Then there's also the call detail records, and those can be stored both in Exchange Online, but there is data that gets temporarily stored on the call detail record servers themselves. So call detail records are things like your activity history, such as your call history, your IM sessions, application sharing, and so forth. That's what we mean by call detail record. And again, like the other content, Skype doesn't partition it by tenant. Instead, it uses RBAC and ACLs to isolate it. Now, SharePoint. SharePoint does some fairly unique things with respect to isolation and encryption, for that matter, because it kind of uses a combination of both. So SharePoint stores its objects as abstracted code within application databases, within SQL Server databases, as SharePoint uses them. So when a user uploads any file into SharePoint or OneDrive for Business, which is the same storage and the same mechanism, that file is actually disassembled. It's cut up into a bunch of different pieces, and each of the pieces is separately encrypted and then stored in different places, multiple tables across multiple databases. And then what that means is if I were to gain access to the table or the database or the storage, I would not be able to put that file together. The other pieces would be missing, and more importantly, it would be encrypted, and I would not know any of the logic that is used to decrypt it or to reassemble the file, assuming I could find where the other pieces are located. So if any of that stuff were to leak or become exposed, or maybe a control fails and a drive isn't recycled properly and now there's data out there, There's nothing anybody could do to get into that data. Only SharePoint Online, only the service code itself would know how to decrypt it or how to do anything with it once it's decrypted. All right, so in addition to the ACOs, though, SharePoint also sets a tenant-level property on everything that is created in SharePoint. And once that's set, there's no way that it can be changed. There's no public or customer-facing APIs that would allow anybody to change that and thereby basically take over or usurp your tenant. And the other thing is once the authentication provider has been set for the tenant, which is set up when SharePoint Online is initially provisioned, once that is done, it also cannot be changed using any APIs exposed to tenant. We could change the authentication provider ourselves, but that would be something where you'd have to call us, get a help ticket going, and then we would start that process and try to do it for you. But there's nothing a tenant or a malicious user could do to change that property outside of that. So every tenant has a unique subscription ID, and that subscription ID is tagged with every site and everything that's done in SharePoint. And again, once that is assigned, it can also not be changed. And the subscription ID is also the key that we use for the security scope when you are authenticating to SharePoint Online. So as I mentioned, we use SQL Server. We do also use Azure Storage for some stuff, particularly the things that SharePoint touches with Office 365 Video. We'll talk a little bit about that in a minute. But at the SQL level, we're also using the site ID as the partition key for the content store, the actual SQL database where the content gets uploaded to once you upload it into SharePoint. Now, there are some file streams that do get shared as blob storage, stored as blob storage inside of Azure Storage as well. And every SharePoint farm that's created has a direct tie to an Azure account, an Azure Storage account that is created specifically for that specific SharePoint Online tenant. So everything that's done is also gated and tied to the ACLs for that tenant. Now, there's also some real-time monitoring that we have in place because we know for a fact that there should never be any queries or any URLs or any requests for data from one tenant that is requesting against the subscription ID of another tenant. That's something that will light up all sorts of flags and red lights in our monitoring system. And that's something that you would never, ever expect the end user to do. Now, we wouldn't expect an end user to do it, but we would expect the service to do it. There are some things that happen in the service. For instance, when we do search, we are searching across multiple tenants, and I'll talk about that in a little bit. But there's nothing a given user should ever do where they're querying within the security context of one tenant where they're actually querying for data belonging to another subscription ID. If we ever see a user doing, that's a huge red flag, and security would get involved right away. But for efficiency purposes, for things like Office 365 search, search is going to make queries within a single security context that goes across multiple SharePoint Online tenants. And we do that for efficiency reasons. I do see a couple hands going up. I'll take them real briefly if they're short. Yes?
So can we get the logs into a CM?
Can you get the logs into where?
CM?
Yes. So that's a good question. So can we get the logs into a CM, Security Event Information Management? Yes, you can, but that is, it's a little different from the information we would see in our monitoring solution. But yes, we have the Management Activity API. If you go to the Security and Compliance Center, so just go to protection.office.com, it should log you in as your 365 tenant. If you haven't already enabled recording, it will tell you right there, click here to turn on recording. If you have, it'll say click here to view reports. So you go to reports, you open up the Office 365 audit log, and then you'll see everything. Once you enable recording for your tenant, any interaction with the data, whether it's a human or the code or a user, whatever it is, all of that is logged as part of the API, and you can pull all that in near real time. For some events. There are some things that will not show up right away. You may need to wait a few hours for certain activities, but eventually everything will be there and you'll be able to look through all that. Yes, I saw another one. So the question is, if you couldn't hear it, does the tenant end up getting any notifications of security incidents? So it depends. It depends on what the incident is. We're not going to tell you every time a red flag comes up in the monitoring system, but if there were ever a breach associated with your tenant or a security incident that affected your tenant, we do have communication mechanisms for that, and we would notify you about that. And just as an aside to that, for those of you who have been in the Security and Compliance Center, if you go into the service assurance area, there's a section called Trust Documents where you can find a bunch of white papers written by me and my team. There's one about security incident management that describes exactly what we would do in that case. All right. Now, Office Graph. How many of you have heard of Office Graph? I would hope almost everyone by now. So Office Graph is super interesting, I think. It's there to model the activity of end users across all of Office 365. So when you think about it, when a typical user's in Office 365, they're doing things like sending email, IMs, uploading documents, or creating new files, and so forth. Everything that they're doing is sending signals or sending telemetry to the system. And the system can use that telemetry and combine it with the telemetry from everyone else in the organization to start creating relationships between all of the documents and emails and IMs that are going on. And these relationships are actually very powerful because they allow you to see kind of what's going on around you within the security permissions that have been assigned to you. So think about the Office Graph not as storing the data that you're working on itself, so it's not storing your emails or files or anything like that, but rather it's storing metadata about that, the relationships between them, how you use them, who you've been emailing, who's been emailing you, those kinds of things. These relationships and these interactions, we refer to them as edges, and the edges have a boundary within a tenant. So there's very rich telemetry that this machine learning system is able to aggregate and bubble up to the end user to increase awareness and knowledge and productivity, but all of that can only occur within your tenant because the edges and the nodes that surround them, the nodes being the places where all this stuff is happening, that is isolated to your tenant. And it's very sophisticated machine learning, so it's not just putting together, for instance, a list of the people that you've emailed. It's looking at their frequency at which you email them, or they email you, or the length of emails, or the subject of the emails, or the nature of the conversation, and so forth. So again, it's not grabbing all this data and putting into a separate repository. It's just leveraging what's going on with the telemetry and the data that's out there, and then creating metadata about it regarding these relationships, and that stores that data in the Office Graph. So there's many different stores that Office Graph uses, like SharePoint, for example. The content is stored at different places, and it's used for different reasons, some for analytics, some for performance reasons, and others just for updating and awareness reasons. And there's analytics within each of the workloads that, like I said, are collecting this telemetry, collecting all of this data, and sending it to the Office Graph so that the machine learning system can look at it and provide new and interesting insights about how the data is being used. And so actually, the first experience that we have is called Delve. So maybe some of you have seen that. If you've used Delve in Office 365, then you have experienced the Office Graph. So it's things like, the people around me, members of my team in the organizational hierarchy, or the documents that my coworker, maybe that my manager or their manager is working on, those kinds of stuff. And in fact, Delve was and is the first experience that was powered by Office Graph. So Office Graph is something that can be consumed. There are APIs, so if you're also a developer, you can go and build against it. But if you're not, we've got Delve, which is built based on the Office Graph API. And because it's based on the Graph API, and as we just talked about, Graph is limited with the edges and nodes to that tenant, Delve is also bound by the API's logical separation as well. All right. Office 365 search, this is going to be probably the most complex workload that we have because of the way in which we do search. So it's not the same logical isolation that we have in the other workloads that we talked about, or Azure Active Directory that we talked about. We do have a tenant separation model, but it's built into the query construction system and not based on just ACLs and RBAC like we have with the other workloads. And we do that for a reason. It's primarily for efficiency reason. It would be, as you might imagine, extremely inefficient to have search target a single tenant at any given time. So when search does its thing, it's reading, for example, in the case of Exchange Online, the entire mailbox database. So we're collecting all of the search and all the keyword and all the information, all the query information from multiple tenants at the same time and storing it within common systems, but we've got a schema and a query syntax that we use and some other things that I'll talk about in a moment that isolate the data from each other effectively and prevent queries, for example, from one tenant from querying data from another and so forth. So the index, as I mentioned, it's a shared index. And the index is stored on the search servers themselves, and the tenants themselves also share the index files. But there are 3 separate independent mechanisms that prevent what you might call leakage through the index. In other words, querying the index and coming up with another tenant's data. So we do both tenant ID filtering. We also have tenant ID term prefixing, which is literally taking the tenant ID and slapping it on every term that's being searched against. And then there's the ACL checks, the actual security permissions as well. All 3 of these mechanisms would literally have to fail in order for search to return documents or data from the wrong tenant. So it is extremely unlikely in the extreme that would ever happen. So I talked about the search prefixes. So when you're doing a search, that could be through Outlook, it could be through SharePoint, it could be the e-discovery tools. Anytime you're doing a search, behind the scenes, when you click the search button or in PowerShell, when you execute that script, we are reconstructing that search to add on the tenant ID to whatever index terms you're looking for. So the example here is someone's just searched for foo. They're coming from a tenant that has a tenant ID of 123, so the full text index entry will actually be 123 foo. So no one else would be able to query that because nobody else would be able to use the syntax for that tenant ID if they were outside of that tenant. The other thing that we do is we also do the tenant ID filtering. You can see the example of that where we do both the search term and the GUID of the tenant ID as part of a single search. So again, there's no way to just search for a single string without your tenant being associated with it in the background. And there's nothing that can be done to interrupt that or circumvent that process as well. Now this tenant ID prefixing we do only on the full text index. So there's fielded searches, which doesn't go against the full text index. It's more doing a live search against the content. That will also run through a synthetic search engine, which will also prefix the tenant ID onto that as well. So you can see what that looks like on the bottom, where we've got the fields, the field name, and then what you're searching for, also with the fields and the tenant ID. So that tenant ID with the GUID will always be part of that search string, and there's no way to circumvent that. So this is what we talk about when we say we've got sort of that balanced approach between efficiency and isolation, where we're doing things in the background, slightly different from what the other workloads do, but we do it that way because of the way in which we search across multiple tenants and construct the full text index with data from multiple tenants at the same time. So here's an example of the ACLs I mentioned. That's the third thing that we do. So every item that gets indexed, everything in the index also has a set of terms and a special ACL field, and that's going to contain either the group or the user that is allowed to view the document. And then down at the bottom here, you can see an example of what that ends up looking like, where we're literally explicitly searching not just for the tenant ID with the GUID, but also each of the individual access control entries that go along with it as well, that are tied to the individual search string. All right, Azure Storage, we talked a little bit about that earlier. There are multiple services that use Azure Storage, Sway being one of them. Hopefully most of you have heard of and maybe even used Sway. And Office 365 Video, which we'll talk about in a moment. Both of those are using Azure Storage for all of their content. And that includes blob storage, so it's not just the straight Azure storage. There's also the Azure blob storage at work. And it's a very simple access control model. Any Azure subscription can create multiple storage accounts, and just like an Azure Active Directory account, that's also gated by the ACLs, RBAC, and the identities in your particular tenant. Now, each storage account also has a secret key, and that key is used to control all access to data there. And this is obviously secondhand nature for storage, where it's designed to really just store data for applications, and applications sit on top of it and control the storage, and therefore control the keys that are associated with that as well. So as I mentioned, again, all Sway data uses that. So after you authenticate to Sway, it's making calls into Azure Storage to pull up whatever Sways you've requested within your tenant. All right, for Office 365 Video, if you haven't seen this, this is an enterprise portal within Office 365 that provides a central repository for posting, sharing, and discovering video content. And all the videos are also isolated, but they're also encrypted as well. So if any of the isolation controls should fail, there's encryption that makes sure that it's only available to the authorized and authenticated users. SharePoint Online stores the actual video file and the metadata, so things like the title, the description, the length, the video format, and so forth. And SharePoint Online is responsible, because it's the storage aspect of it. It also is responsible for using its integration with Azure AD for the authentication layer as well. And then we use Azure Media Services for the transcoding. And so there are some data that does get stored within Azure Media Services, and that data gets stored on demand when a user goes to play the video. We look at the device that they're playing it from, and we transcode and render that appropriately for that device. So it could be a very small video file if they're watching it on a phone, or it could be a regular normal-sized video if they're watching that on a desktop computer, for example. But either way, that's something where Azure Media Services is doing the transcoding, but Azure AD is still doing the authentication layer to get to that. And everywhere, by the way, everywhere we have Azure Active Directory and data centers, Azure Media Services is also stored in there as well. All right, so the other aspect about this, so we've talked about up till now how we are logically isolating data across the primary workloads and several other workloads. But remember, the second goal of a multi-tenant environment and making sure that tenant isolation is good is the resource limits and the monitoring, and basically making sure that one tenant can't do something in the service that's going to adversely affect the service or another tenant. So that's why, given the nature of our service, given that it's literally designed to run a very, very diverse set of workloads from a very diverse set of customers, we have resource limits, quotas, throttling, et cetera, that are built in all throughout the systems. So that's Azure AD and Office 365. They all have throttling and resource limits. The limits themselves are generally unique to each workload because they're workload specific. And they will evolve over time as the service evolves. And there have been cases where we have raised the default limits for some customers who were just so large that the limits really didn't make a lot of sense for them. So there are possibilities to call in and get things raised from a performance standpoint, doing a big migration, for example, or you just bought another company, now you're doing a merger and you're ingesting all of their data into your tenant. Those kinds of things we understand are going to happen, and you can always call us and ask support to work with you on increasing that. But in the absence of that, there are hard-coded limits all throughout the service and workloads that, like I said, prevent one tenant or one user from doing things that they shouldn't. So for instance, Azure AD and all of the Office 365 services have limits on what a single user can do. Okay? How many transactions they can do. So a transaction could be sending emails with respect to Exchange Online, could be uploading files with respect to OneDrive, could be downloading files with respect to OneDrive and so forth. But whatever actions they're taking, there's a pretty good chance that there's limits on them. Now, each tenant also has a default PowerShell throttling policy as well. So we'll limit things that the end user may be doing through PowerShell, but we'll also limit things that an administrator might be doing through PowerShell as well. We don't want the admin to do things that would cause unnecessary resource constraints. And then as an example, Exchange Online has web services limits, so that no client, if they're doing development or they're using EWS just to fetch data, there's nothing that they can do that's going to tip over the system because we limit the number of queries they can do and the amount of data that they can get back as well. And like I said, these types of throttling features are very important given that we're a global service that is run by a very diverse set of customers. Now, we continuously monitor. Yes, sir? Say that one more time. Great question. How would an administrator get notified that they're being affected by some limits? Well, there are a couple ways. One way would be to go to TechNet or support.office.com, where we have documents that talk about limits. So for instance, we've got Exchange Online limitations, SharePoint Online limitations, and so forth. Other ways an administrator could find out is that they try to exceed one by taking some action, and the action returns some sort of error messages that says something like throttling kicked in, or you're over your resource limit, or it might use some internal jargon that might talk about bucket allocations and things like that. Those would be indications that you're hitting those limits. The best place, what I would recommend is read the documentation where we document all the limits, and it's very granular. We talk about PowerShell, the individual workloads, the protocols, the APIs, size limits, things like that. Familiarize yourself with all those limits, and if you see a limit that looks like might be a problem for you, maybe give us a call and talk to us about it, or try to do the action and see if you can succeed or not. But generally, you shouldn't find them too intrusive. They're not there to stop you from doing things you need to do. They're just there to stop people from doing things that impact others on the shared service. So, but that I would definitely start with the documentation on that one. Yeah. Sure, yeah. So the question is there inline error handling? There is some. Some of it you may need to construct yourself through your own PowerShell script, but you certainly could trap error result codes, for example, and then take different action based on that. You'll also see resource limits being hit in the audit log, the unified audit log, so through the activity API. And like I said, if you're just executing something, maybe you're doing a batch import of something, it'll come back pretty quickly if you're hitting a limit. All right. Okay, so we continuously monitor, we're continuously testing. We do a lot of things like red teaming, blue team, and so forth. We use multiple internal systems, plus we also use what we call outside-in monitoring as well, and that's literally monitoring the service, both resource utilization and health, from an external standpoint. And the service itself is largely run by software. So humans govern the service, but really software runs the service, code runs the service. So there's a lot of monitoring and testing that goes on where the service itself will see something as unhealthy because of resource consumption, and it can do things like automatically recover by failing over to somewhere where there's resources available. And all of that stuff, all of that logic happens automatically. There's nothing that an end user would ever need to do. There's nothing that an administrator would ever need to do. It's nothing that you would ever need to call us for. The system looks for deviations, recognizes that behavior, and takes appropriate action based on that. All of that self-healing stuff has been architected right into the service. But that being said, we do have Microsoft on-call engineers that are there 24/7. Any Sev1 security escalations, which would be a breach or an attack, all of those are handled in near real time. And regardless of the outcome of them, we do full post-mortem reviews. And that helps us with continuous learning, behavior analysis, and other growth mechanisms as well. So regardless of the magnitude of impact, whether it's a small thing or a very serious thing, everything gets reviewed, not just by the security team and the trust team, but also by the senior leadership team in our monthly service reviews as well. Now, many of you have heard about how we defend the service. We use two mechanisms or two mindsets, if you will, one being prevent breach, and so that would be all the security processes that we have, like the security development life cycle, the postmortems, and so forth, and all the testing that we do. But we really also take this assume breach posture. Okay? We just assume that eventually the bad guys are going to get in, or that maybe an internal person might either get compromised or might turn out to be malicious and want to do bad things. So we do a lot of work around assume breach as a result of that. Now, having said that, you'll probably see us evolving once again, not just through assume breach, but also with a sort of a protect posture. Right now, the protect posture is there, but it kind of takes a secondary or back seat, if you will, to the assume breach mindset. But I think what you'll see, given things like last week's Internet of Things, malware attack, and some of the other things that are happening, you'll see us moving back towards more of a protect posture than just assume breach. We'll still do assume breach because it's a very valuable mindset from a security standpoint, but I think you'll see a protect posture coming up even more. The way we execute assume breach is we've got two teams. We've got the red team. Those are the bad guys, if you will. They're the ones trying to hack into the system. And then we've got the blue teams, the good guys, who are there to defend against and basically catch the red team or stop the red team from doing things. Both Azure and Office 365 staff red and blue teams. They're separate teams, so Azure has their own and Office 365 has their own. And we do have a mantra: the red team is not allowed to do any harm, and the only tenant they're allowed to attack is the actual Microsoft tenant, so our corporate tenant, which is in Office 365. And if they get in and they find a breach, they're not allowed to do bad things. They can do no harm, so they can't go in and start deleting mailboxes or whatnot. And again, the blue team is there to look for them. They're looking at our telemetry, our monitoring, all the systems that are in place to check for these things, trying to find any evidence that they're there and to stop them and remediate any vulnerabilities that are found. And this goes on continuously, 24/7, 365 days out of the year. All right, so in summary, you can see that we've got multiple forms of protection in Office 365 and Azure Active Directory, and that includes things like the authorization and RBAC model that we have in Azure, and the fact that all of the sessions are either tenant scoped or user scoped, and that unless an administrator takes explicit actions to allow sharing outside of a tenant, by default there's no sharing outside of a tenant, and there's no service code or anything that can execute commands across or from one tenant into another tenant as well. And then the last thing I'll mention is there is a whole white paper that we have on this as well that is also available for download from the Service Trust portal or the Service Assurance Dashboard, which is part of the Security and Compliance Center, or protection.office.com. Both of them require onboarding, so you have to have an Office 365 account to get to both of these places, but it can be a trial account. It doesn't have to be a paid account. And when you're there, you can get the Tenant Isolation white paper, lots of other white papers that we have, and literally the audit reports from the various audits that we go through, ISO, SOC, and some of the other United States and international audits that we end up going through as well. So I would highly recommend, if you've got an Office 365 account, probably the easier way is to go through Service Assurance. But if you don't have one, you might check out the Service Trust portal because that is, it's a portal that was written and designed and controlled by the Office 365 Trust team, but it was actually implemented as a third-party Azure app, so it doesn't have the seamless experience that the Security and Compliance Center has. So that's why I recommend that. And then the other thing I would say is if you are running Exchange on premises, I told the Exchange team that I would promote the fact that we do have a technology adoption program. So if you're hybrid or you still have Exchange on premises and you want to join our pre-release program, you can visit the blog or give David an email and join and help us with that. All right, so with that, don't forget to do the evals and stuff. And I think I could probably take a few questions, and then I got to jam across the street to the ballroom. But I will also be at the happy hours and in the hub. And like I said, feel free to email me if you don't get your question answered. Are you guys still awake? I know you had lunch, and then we put you in a dark room, so. All right, well, thanks very much for coming, and hope you enjoyed the rest of the show.